For this problem, we're going to use this table of data and the conditional probabilities listed there to answer this question, a probability that two different randomly selected defendants both entered guilty pleas. And so we need to know how many total entered a guilty plea. So this column are all the people who entered a guilty plea. Those two numbers add up to a total of 946. So out of the total 1,024, all of these numbers together add up to 1,024. 946 of them entered a guilty plea. So 946 out of 1,024, that's the probability that a randomly selected person enters a guilty plea. So if we want to know the probability that two randomly selected defendants enter a guilty plea, we need to realize these are independent events. One person's plea doesn't affect the other, so they're both going to have the same probability of entering a guilty plea. And so you just take the probability of each person's plea and multiply those together to get the probability that they both enter a guilty plea. So in this case, it's that about 92% here multiplied by that same value, for they both have the same probability of entering a guilty plea. And so for getting two people randomly selected to enter a guilty plea, this would be the probability. For this next problem, we have another table of data that we're going to use for conditional probabilities. Here is pedestrian deaths. And the question we're trying to answer is if one of these deaths is randomly selected, what's the probability that the pedestrian was intoxicated or the driver was intoxicated? So one way to do this is just to add up all the numbers to get the total amount of deaths that involved intoxicated one way or the other, either pedestrian or driver. So the pedestrian intoxicated would be this yes column. I would need to add the 51 plus the 263. And then the driver intoxicated, I would need to just add this 83 here. I've already added that 51 in, so I don't want to double count those. So I would just add in this 83. So those three numbers together account for all the deaths that involved someone being intoxicated. And so if we just take that number out of the total, which is 974, we get the probability that a randomly selected, one of these randomly selected deaths involves someone that is intoxicated, and there is the probability. In this next question, we're again looking at a table of data here involving pedestrian deaths. And we're going to answer this conditional probability question. If two different pedestrian deaths are randomly selected, what's the probability that they both involve intoxicated drivers? And so we need to find out the total number of deaths that involved intoxicated drivers, which would be that 65 plus that 82. And so it's that many out of the total that involved intoxicated drivers. And so the proportion here, which gives us the probability, is that out of the total. And so this is the probability that one randomly selected pedestrian death involves an intoxicated driver. Now, if we're looking for the probability of two, we need to multiply the probability that it involves an intoxicated driver in each scenario together. And these are independent events. One situation involving an intoxicated driver does not influence the chances the next one does. They're both going to have this same probability that an intoxicated driver was involved. So for two randomly selected incidences, we multiply that same probability together, and this is the probability that they both involve intoxicated drivers.